for which values of the exponent r is the integral from 1 to infinity x to the r dx convergent. We first set up the improper integral properly by taking the limits at b go to infinity of the integral from 1 to b x to the r dx. This is equal to the limits at b go to infinity of x to the r plus 1 over r plus 1 by using the antiderivative of x to the r. We then evaluate it from x equals 1 to x equals b. This simplifies to the limits at b go to infinity of b to the r plus 1 in the exponent minus 1 over r plus 1, where r needs to be not negative 1. If the exponent r plus 1 is positive, that is, r is greater than negative 1, then the term b to the r plus 1 approaches infinity, or that limit doesn't exist, so the entire integral is divergent. If the exponent r plus 1 is negative, or r is less than negative 1, then the limit of the term b to the r plus 1 go to 0 as b go to infinity. It is because the exponent of this positive number b is negative. But if the term go to 0, then the limits of the integral is negative 1 over r plus 1, where r is less than negative 1. This number is a finite number, so the integral is convergent. If r plus 1 equals 0 or r equals negative 1, then the integral is ln of b, but as b go to infinity, ln of b go to infinity, so the integral is divergent. Thus, the values of the exponent are such that the integral from 1 to infinity x to the r dx is convergent is when r is strictly less than negative 1. This result is known as the p integral, the integral from 1 to infinity of 1 over x to the p dx. So in this case, p is negative r. Replacing r with negative p, we see that the integral from 1 to infinity of 1 over x to the p dx is convergent if p is strictly greater than 1. This result is used quite often, so we will summarize this here. The improper p integrals, the integral from 1 to infinity of 1 over x to the p dx, is convergent if p is strictly greater than 1 and divergent if p is less than or equals to 1. The result is also true if the lower limit of integration is a number that is more than 1. For example, the integral from 2 to infinity of 1 over x squared dx, since p equal 2 is greater than 1, we know that this integral is convergent. Or the integral from 10 to infinity of 1 over the square root of x dx, in this case p equals 1/2, which is less than or equal to 1. Thus we know that this integral is divergent.